1.5 degrees and net zero. These two phrases have been core to the vocabulary of climate policy and debate ever since they were brought to the attention of the world back in COP21, Paris 2015. Both of these phrases can trace their origins back to work by Professor Myles Allen, our guest this week. Myles is Professor of Geosystem Science at the University of Oxford, and he's affiliated with the Oxford Martin School, an interdisciplinary institute which brings people together to work on the challenges of the 21st century. So you might think, well, this is a bit of a historical episode that we're going to have. I know what 1.5 degrees means. I know what net zero means. Or do I? Right? I mean, let's think about net zero. The planet is carbon neutral in a sense. We're not losing carbon to space. We're not gaining any carbon from space. So the planet is carbon neutral. But maybe net zero means the atmosphere. I mean, after all, it's the atmosphere which is causing global warming, and it's because we've got too much CO2 there. So we've got to stop putting CO2 in unless we compensate for it by taking CO2 out. That sounds pretty plausible. But that's not right. And we'll learn very soon why that's not right. One final thing, I had a horrible snafu recording this. We had a connection issue, and when we came back online, I forgot to hit the record button again. So we lost the very end of the conversation. I have tried to recreate that based on my own memory banks and just recount Myles's responses in my own words. It's not as good as Myles, and I apologize to you folks, and especially to Myles. But despite that, this was a really wonderful conversation. It's such a big topic, obviously, climate change. But it's great how Myles is able to get us back to some of the key points and also just make it seem, well, not make it seem, but point out that this is something that we can address. I'm James Robinson. This is Multiverses. Myles Allen, thank you so much for joining me on Multiverses.
Well, thank you.
We're going to start with a question which I think many people will think they know the answer to, but you are perhaps the number one person to ask. What is net zero?
Well, the original idea came back in the late 2000s when we were looking at what it would take to stop global warming. And what we found at that time, the goal of climate policy was, in the words of the Rio Convention on Climate Change, stabilization of greenhouse gas concentrations in the atmosphere. So everybody was arguing about, should we be aiming for 550 parts per million, 450 parts per million, whatever. And what we established was that, well, first of all, we found that it was very difficult to pin down what concentration we should aim for, because it was very hard to predict when the warming would stop if all we did was stabilize concentrations. But what we found was that if you stopped releasing carbon dioxide into the atmosphere entirely, and that's important to stress, if humans stopped releasing carbon dioxide into the atmosphere entirely, then concentrations wouldn't actually stabilize. They would actually start to fall a little bit, just enough to stop temperatures rising any further. So that was the origin of the idea of net zero emissions being what it takes to stop global warming, was the observation that if we stopped actively dumping carbon dioxide into the atmosphere, then Mother Nature would then immediately start to draw carbon dioxide back out of the atmosphere, not fast, but just fast enough to stop global temperatures from rising any further. But it is important that it's not a stable state. It's not a state in which nothing else is changing. It's actually more of a dynamic equilibrium in which deep oceans are warming up, atmospheric concentrations of carbon dioxide are gradually falling. These two things are balancing out, and you end up with no further warming or cooling of the Earth's surface.
It's quite fortuitous, I guess, that if you stop emitting, nature does exactly the right amount of work that you need to stabilize the temperature. I mean, is there any kind of deep reason for that you can kind of précis,
Well,
or is that just luck?
yeah, I mean, there's actually a lively argument going on still about whether there's something deeper or whether it's just luck. And I happen to be more on the side of it's just luck in that argument. There are certain timescales that it makes sense are similar. So, for example, the deep ocean is playing a role in both the ongoing uptake of carbon and also in the ongoing adjustment of temperatures. But there's other things involved as well, which you wouldn't sort of expect to have the same timescales. So, in some respects, I think it's more just a matter of the fact that when lots of processes added up, you end up with an answer that is more or less zero.
And just to emphasize the fact again, then, that if we were to stabilize concentrations of CO2 in the atmosphere, and we set that as the target, and that would result in additional warming, right?
Absolutely. If we were to stabilize concentrations of greenhouse gases at today's level, then we'd probably see maybe half as much warming again as we've already seen. So that would take us close to 2 degrees just with today's concentrations of greenhouse gases, never mind what we'll get to by mid-century or whatever. So that's why, and it could take us much well beyond 2 degrees. It's very hard to pin down when the warming would stop if we were to do nothing else but stabilize greenhouse gas concentrations, which is why it's so important we have to go beyond that and actually reduce emissions all the way to net zero. Stabilizing, there's another side to the coin, of course, which is that stabilizing concentrations of greenhouse gases is actually a much easier goal. What it would require you to do would be to reduce emissions by about 50% initially, then another 50% within 20 years or so 75% overall. And then after that, you could carry on emitting for quite a long time, several centuries at a much reduced level, and still see concentrations of carbon dioxide in the atmosphere remaining stable. I'm really stressed. I'm talking about carbon dioxide here, which is the big one. It's the main greenhouse gas. Other gases behave in more complicated ways, but this is the important one. And so that's why that's why in many ways the Paris Agreement was such a remarkable achievement, because the parties to the Paris Agreement had to accept some really quite uncomfortable new science, and they took it on board remarkably quickly. And we published all these papers in 2009, and the Paris Agreement was reached in 2015, so only 6 years later. And in particular, it meant developing countries who, before net zero were kind of assuming they'd be able to carry on emitting. It would only really be the developed countries that would have to stop emitting. That they'd be the ones who'd be still emitting at this sort of lower level, because their emissions were much lower to start with. Accepting that they too would have to get to net zero. So, I mean, that's one of the things about net zero is it involves everybody. Or more to the point, it involves everybody. Of course, it doesn't necessarily mean that everybody has to do an equal amount, and it's only fair, obviously, for rich countries to do more than poorer ones. But it does mean that if anybody's still emitting at the date of net zero, somebody else has to be taking that carbon dioxide back out again. So, overall, the world has to get into balance.
It is a crucial message, though, that I think has perhaps been lost since the original statement of net zero, that it doesn't mean net zero emission, net zero CO2 into and out of the atmosphere, right?
Yes, that's incredibly important, and that has been badly misunderstood in recent years. And it's sort of understandable that people. Okay, probably the scientific community is partly to blame here as well. For maybe we didn't explain it well enough. But when people look at the fact that the biosphere and the oceans, between the biosphere, meaning sort of trees, plants, soils, and so on, between them, the biosphere and the oceans are currently taking up 20 billion tons of CO2 per year, more or less. And our emissions are around 40 billion tons.
Mhm.
So when you look at that 20 billion tons, you might think, well, that's great. I mean, if we just halve our emissions, then surely the Mother Nature will take care of the rest. Well, unfortunately, that's not how it works. What that 20 billion tons is, it's a redistribution of the carbon dioxide we're dumping into the atmosphere, into the land and near surface oceans. Some of it's trickling out into the deep ocean. But because it's a redistribution, not a permanent sort of drain. It's not as if there's a plug hole that all the carbon dioxide is draining out through. That carbon is permanent. If we release carbon into the system, it stays there forever. It's just being mixed around between different carbon pools. And that means, of course, if we reduce our emissions, immediately the rate of uptake by the land and ocean will decline along with our declining emissions. So we can't just count on these so-called natural sinks carrying on taking up carbon at the rate they're doing at the moment as we reduce emissions. And of course, there's another really important potential problem. As everybody knows, we're seeing greater incidence of forest fires in many regions, greater incidence of droughts, which release carbon back into the atmosphere.
Mm.
So carbon that was being mopped up by a natural ecosystem could get released back into the atmosphere if the climate changes in such a way that that ecosystem is no longer viable, or that forest burns down, or whatever. And we're seeing increased incidence of this kind of what we call Earth system feedbacks, which is potentially making it even harder for Mother Nature to mop up the impact of our emissions.
I think it's also the case. You'll know much better than me that as the planet warms, we're seeing a very fast rate of plant growth right now because carbon is high at plants like that. But as the planet warms, vegetation won't like that new regime, and we'll see a reduction in the growth rate there as well. So we sort of might, there's a lot of feedbacks going on.
But I wouldn't want people to sort of get the impression that, oh, it's horrendously complicated. They don't really understand it. I mean, we do understand in the big picture. We don't understand the detailed numbers. There's a lot of important uncertainties to be resolved here. But the big picture is pretty clear. You know, as you say, plants are growing faster at the moment because of the fact, two things. We've got more carbon dioxide in the atmosphere, but also we've recently increased the amount of carbon dioxide in the atmosphere. Both of those drive a sort of imbalance between atmosphere and the biosphere and the oceans, and they're effectively driving CO2 out of the atmosphere. But both of those and the contribution from the recent increase, of course, would decline rapidly if we were to reduce emissions. But we are absolutely counting on that ongoing uptake by the biosphere and the oceans after we get to net zero to stop global warming, to stop the global warming getting any worse beyond that. And one concern is that increasingly people are looking to those sinks as a handy way of offsetting ongoing emissions. And that really is double counting. You know, we're already counting on Mother Nature doing the work for us. So if we pretend it's not Mother Nature after all, it's us, and we can therefore take credit for it and continue to, you know, carry on burning fossil fuels because of those processes that are going on, then we won't stop global warming at all.
Yeah. This is the danger. It reminds me of this classic kind of paradox where, you know, if you marry your cleaner, you reduce the GDP of the country, right? And it's just an accounting. You know, it's not that anything different is happening. This is probably quite a antiquated example now, right? But assuming that your cleaner continues cleaning your house as your wife,
Right.
then
okay,
right.
that does. Yeah, no, that's a good point. Yes, yeah, no, I was trying to work out what the analogy was, but I get it.
It's rather a tenuous
I
one,
yeah.
But you know, it's a process. The point is, there's a process that's going on already. Plants taking up carbon dioxide, and suddenly you say, "Oh, well, that's me. I'm doing that, right? This forest growing on my land, you pay me for that, and you can have some carbon credits, right?"
Well, the crucial point is not you pay me for that, but you can have some carbon credits. So, and this is where, so the problem is the idea that this natural carbon uptake is compensating for ongoing fossil fuel emissions. And you can understand why people feel this. They say, well, a ton of carbon is a ton of carbon. It's going into this forest. So therefore, the carbon I release to the atmosphere is being offset by this, growing forest. And unfortunately, maybe we were naive, as I say, but when we as scientists established the case for net zero back in the day, it didn't occur to us, perhaps it should have done, it didn't occur to us that people would want to take credit for that natural process. Part of our reasoning was that we didn't think it would be possible to measure it. So if you go back and look at those papers, we regarded the response of the biosphere as a global natural phenomenon that one would have to model. But the idea that anyone would actually be able to say how much of it was going into what patch of land, at that time, we didn't have the technology to do that. Now, technology's moved on. You can now actually monitor carbon uptake in considerable detail. We have spaceborne satellites, we have airborne LiDAR, and all sorts of technology that actually allows us to document in a lot of detail what's happening in a particular location, and it therefore makes it possible for people to say, well, my farm or my park or whatever is absorbing this much carbon per year, so I want to sell those on the offset markets, and so it's a matter of technology evolving beyond what we sort of even thought of only 15 years ago.
I mean, is it right to think that some of those, some of that could be legitimate carbon that would not have been taken out of the atmosphere if you're building, if you're putting a forest in a place where for hundreds of years there was nothing, and if you've done nothing, no forest would have grown, then that seems like a legitimate new carbon sink. But the danger is where there's already existing forest or something was growing, and then you take credit for what was just happening naturally anyway.
Yeah, I mean, the difficulty is actually establishing that, what's called in the jargon, additionality, proving that carbon is being taken up that clearly would not have been taken up otherwise, can be really hard, particularly when for example, nature's pretty good at identifying regions that are suitable for forests to grow. So, if a forest could grow in a particular region, it's probably because it's been deforested already, and so in a sense, you're just sort of allowing it to recover to what it would have been naturally. And that sort of allowing the biosphere to recover is the process that we included in the models,
Right.
and led us to the conclusion that net zero emissions would stop global warming. So if you then take credit for just allowing the biosphere to recover, it's it's not consistent. I'm not saying it's wrong, but I can say it's not consistent with what we defined as net zero back in the day. Now, that said, of course, you could do more than that. For example, you could, instead of, you could take a region which was sort of naturally have a relatively slow growing forest on it and plant it up with some fast growing fuel species, which you then harvest and you burn and you bury the CO2 back underground, for example. This is sort of bioenergy with carbon capture and storage. I mean, that would work, as it were, in principle, to take carbon actively out of the system. The catch, of course, is that many people worry about that happening on a very large scale because, of course, we want our old growth forests to preserve biodiversity and, provide all the other services they provide, and not necessarily turn them all into fuelwood plantations.
Yeah, I want to come back to this bioenergy, carbon capture and storage, the Beck's point, and what the alternatives are there. Firstly, though, you've recently, or over the last few years, been talking about geological net zero. Is that just net zero, but
Well,
repackaged to make it clearer?
yeah, I mean, it's what we meant by net zero. If you actually go back and look at the original papers, we did not
Yeah,
envisage a big role for the land surface in net zero. The original papers looked at what happens in a model when you just stop dumping fossil fuels in
yeah,
the atmosphere, and stop active land use degradation. That was what we regarded as net zero. So this much more um, general sense of net zero is really a relatively recent creation, if you like. Perhaps partly because it's, as many people have made net zero commitments, they've sort of then realized actually those are going to be quite difficult. So they're looking around for ways of delivering them.
yeah, yeah. So I mean, I really like the term geological net zero because it it makes it quite clear what the system is. That you want to have a net zero transport to and from, and it's the crust, right? You
Yes.
don't want any carbon that you take out of the crust, you got to put back.
Yes. And the advantage of it is that unlike the biosphere, which is fluxing carbon on a massive scale into and out of the atmosphere all the time. There's huge cycles of carbon dioxide every year between the oceans and the land and the biosphere and the atmosphere. There are no significant natural um, carbon sources and sinks in the geosphere relative to, I mean, there are some, obviously. Volcanoes trickle a small amount of carbon into the atmosphere. The subduction of ocean seabed tucks carbon away back in underground. But as you might imagine, those are, the subduction of the Earth's crust is a pretty slow process. So
Yeah, I don't want to
it,
rely on that to solve.
exactly, it's not, and it's also quite predictable. We know how much carbon is being sort of, and it's tiny compared to the fossil fuel release. So it's just much simpler. We will know when we get to geological net zero. Um, you know, right now, the way everybody, if you just think of net zero as sort of net zero everything, including the biosphere and the oceans, I really worry that, within 20 years, so to speak, I mean, either way, uncertainty, we might not even know when we've got there. So
Yeah,
we've got this great target, but it's got so fuzzy that we won't even know if we've met it.
yeah. Coming back to this idea of additionality, I think one of the attractive things about growing more forests is that seems like a very environmental thing to do, and we've got into this problem by doing lots of industrial technological developments. And there's clearly a camp who would like us to get out of it via a different route, and I'm sympathetic to that. And there's all sorts of other reasons that you kind of alluded to why you might want forests. But as you say, it's quite hard to attribute that to the results of human activity and not something that would have happened otherwise. Whereas with putting carbon back into the crust, it's entirely the opposite. Like that wouldn't have happened unless you're sort of, I don't see anyone trying to count their subduction zone as part of reducing the carbon content. Maybe Iceland could get into that, but probably not.
Yeah, no. I mean, that's right. I mean, you put carbon back into the Earth's crust because you decide to do so. It's not going to happen by accident. Um, by the way, there is still a little bit, just for completeness, there is still a little bit of an additionality question mark
Mhm.
over some activities that involve putting carbon dioxide back into the Earth's crust. And that's that actually the oil and gas industry does use carbon dioxide to flush out hydrocarbons in
Mhm.
enhanced oil recovery and enhanced gas recovery from hydrocarbon fields. In fact, most carbon dioxide that is injected into the Earth's crust at the moment is done for that purpose. So it's not really done for any climate purpose at all. It's done for the purpose of extracting more fossil fuels. So there is a bit of an additionality question to be raised there. Is like, well, okay, it's not a natural process, but you could argue it's a process that's going to happen anyway because of the profit motive. If it's profitable to inject CO2 for enhanced oil recovery, maybe people shouldn't take credit for that as a climate mitigation measure. But in the grand scheme of things, that's actually a relatively small scale activity compared to the scale of the disposal of CO2 challenge we face. So I just thought I should mention that for completeness, because it's important to stress that these things are not always completely unambiguous. And indeed, many people do grumble a bit about the oil and gas industry taking credit for something that's actually perfectly profitable already, claiming they're sort of doing wonders for the climate by just putting CO2 back underground.
Right. There's, there's something that, I can imagine it doesn't feel right, but on the other hand, I mean, yeah, it may become a valuable. Like I
On the
actually
other
think,
hand, it does get rid of CO2.
yeah,
And CO2 back underground is better than CO2 in the atmosphere.
yeah,
So maybe we shouldn't be too precious about why people do what they do.
yeah. And I think I was talking to actually an Oxford graduate, Ruta Cariolita, about hunting for natural hydrogen, and I think it's also among the processes that are being looked at. Injecting CO2 infused water to flush out natural hydrogen reserves. And there you think, well, fair enough, right? Because that's a clean fuel, and we'd be getting rid of carbon dioxide in the process. So, yeah, if we're going to have a rule about this, it seems fair enough to count that as a carbon sink.
And you could also make a perfectly coherent argument that an oil and gas industry that's putting carbon dioxide back into the Earth's crust at the same rate that it's extracting embedded carbon dioxide in the form of hydrocarbons, that is, at the same rate that carbon dioxide is being generated from the hydrocarbons it's extracting from the Earth's crust, is doing the right thing by the climate. Certainly a better thing by the climate than not putting any carbon dioxide back at all. And so, as I say, perhaps it's important that we're not too precious about exactly how the industry goes about it. We should just focus on the outcome.
Yeah, this is a very topical point. Obviously, we have COP28 coming up, headed by the CEO of the Abu Dhabi National Oil Company, Sultan Al Jaber, and taking place in Dubai. So there's a lot of expectation that people are, that big oil, big gas will be looking to put forward their agenda. Does that necessarily? Can we be hopeful that actually part of their agenda might be consistent with a path to net zero?
I mean, they've got to be part of the solution. We're not going to deliver this by just fighting them. They're too big, and they've got, and in many parts of the world, they're too central to economies like the economy of Saudi Arabia or UAE, to simply suggest that industry should just crawl away and die and be parked in the corner. So I think there's a sort of pragmatic reason why they should be part of the conversation. There's also, I feel, an environmental justice region. I mean, they've sold a product that's caused the problem, so they should be held to account to clean up the mess. So I actually feel it's letting these companies off the hook almost to say we're just going to stop using fossil fuels eventually when we manage to, or we're going to try and stop using fossil fuels as fast as possible. I don't think that's good enough. I think we need the industry and its customers, which of course includes you and me, to not only stop putting more fossil origin carbon dioxide into the atmosphere as soon as possible, but also to put money into getting rid of it. Because one thing's for sure, we are going to generate more carbon dioxide from burning fossil fuels than we can afford to dump in the atmosphere if we're going to meet Paris goals. I mean, this is clear from, if you just think about the numbers, when we published the net zero papers back in 2009, we'd recently burnt as a species around 500 billion tons of fossil carbon. So, and you burn all that, you generate just under 2 trillion tons of carbon dioxide, and that's enough to cause 1 degree of global warming. In the 15 years since then, we've burned through another sixth of a trillion, or we've burned a third of the way through the next 500 billion tons, which would be enough to take us to 2 degrees. And of course, in the meantime, we've had the Paris Agreement, which has meant that we've agreed to try and limit warming to 1.5 degrees, which of course cuts down the budget remaining from the other direction by 25%. So, you can't, and we haven't started reducing emissions. Emissions are still as high as they ever were. So I think it's almost dangerous now to claim that it's possible to solve the climate problem without getting rid of carbon dioxide on a very large scale. We are going to make too much carbon dioxide, and we will have to get rid of it permanently. And the only way of doing that anyone is sort of doing on any scale at the moment is injecting it back into the Earth's crust. So if somebody comes up with another way of doing it, turning it into chalk or whatever, that's fine. More power to them. But at the moment, that's the option that's available to us. And if you just look at the numbers and the rate we're going to need to be, by the end of this century, we're going to need to have disposed of hundreds of billions of tons of CO2 permanently back into the Earth's crust. And I think we need to be holding the industry to account to develop the technology to do that, rather than just, hoping it'll go away. Which is why I felt when Sultan Al Jaber said, as he did back in May, we need to be laser focused on phasing out fossil fuel emissions, I thought that was a positive. Yes, he's acknowledging that we will probably still be using fossil fuels after we phase out fossil fuel emissions, but we will build the technology to get rid of the CO2 so we don't emit it into the atmosphere. I thought that was a positive. And I was actually a little disappointed with the reaction from lots of people in what you might call the climate establishment, which was that, oh no, we should focus on just phasing out fossil fuels altogether. I think phasing out fossil fuels altogether is effectively letting the industry off the hook.
I think you mentioned the pragmatic reasons for dealing with such a large industry, and I mean, there's another set of reasons, which is just that they have all the expertise and the kind of infrastructure almost ready to go to put carbon back. I mean, you run the pipeline in reverse to a certain extent. I mean, not always as easy as that, but you can certainly use existing oil and gas pipelines to transport carbon. You can use geologists to go find places to put the carbon and to understand that it will stay there reliably. Therefore they have a lot of the technical expertise that's needed to undertake this sort of operation. Project management, large scale infrastructure, all those sort of things. So it would be it seems kind of foolish to ignore all that and hope that we can do this without them, create a separate industry that will do this.
I agree. The flip side of that, of course, and the reason why so many people are so suspicious of this approach is that the industry hasn't exactly covered itself with glory over the past 30 years, and a lot of people feel they just can't possibly trust them at all. And a lot of people are worried, I think understandably so, that carbon capture may be proposed as a solution to sort of kick the can down the road another few years. And then, so for example, if the industry said, don't worry about it, we can get rid of our CO2, and we say, okay, fine, go for it. And then they get to, 10 or 20% disposal, but then discover it gets a bit difficult after that. And then they say, sorry, we can't go beyond 20%, but we're still addicted to fossil fuels. So we haven't actually done the work to get off fossil fuels. That obviously would be a bad outcome because, we need to go reducing emissions by 10 or 20% is not going to cut it. We've got to get all the way down to zero. I can understand why people are worried. On the other hand, it's an and, not an or. We need the industry to be cleaning up, and we need to be reducing the rate at which we use their product. We need to do both. The problem at the moment is that people see it as an or, that we can, if we tighten our belts hard enough, we can do without CO2 disposal by just stopping generating CO2 altogether. And, all of the evidence points to the fact that it's just too late for that.
Yeah. But, I mean, it seems that there's no reason to think that there's a kind of limit on how much carbon we can, take out of the atmosphere and put in. And so, obviously, the industry could tell us that thing, but it, say, oh, we've tried our hardest, we can't do any more. But it seems like we would be able to hold them to account. As you say, we probably don't want to put all our eggs in that basket, right?
Well, absolutely not. But in a sense, the industry's eggs are already in that basket. They're counting on this tag. If we're going to stop global warming, and they want to carry on in business, if we're going to stop global warming in time to meet the goals of the Paris Agreement, and the industry wants to remain in business at all, it's totally dependent on geological disposal of CO2. And yet it's sitting around waiting for someone else to pay for it. This is where I get, slightly exasperated with them, is they seem to think it's reasonable for the taxpayer to pay to clean up the mess caused by them selling an extremely profitable product. I mean, just to put this in perspective, the cost with today's technology of recapturing carbon dioxide from the atmosphere, that's the most expensive option. You actually go to hoover it back out of the atmosphere, and re-inject it back under the North Sea, would be around $250 per ton of CO2. That's sort of academic estimates of what this would be, and who knows what companies would want to make a profit in doing that, but that's kind of roughly what people reckon it would cost. Now that translates into 4 pence per kilowatt hour of natural gas. We currently, that's the amount by which the price cap on natural gas went down last month. So, and it's not as if, and by the way, so 3 years ago, natural gas in the UK, domestic natural gas prices, if you shopped around, you could get natural gas for 2 or 3 pence per kilowatt hour. Last year, we were spending well over 10 pence per kilowatt hour, even with the government price cap. So the cost of delivering that gas hadn't changed at all. So someone was making plenty of money. In fact, they were making more money in selling natural gas than it would have cost them to dispose of all the carbon dioxide it generated twice over.
So they could have disposed of the CO2 and still made money.
They could have disposed of every single molecule of CO2 that gas generated and still made money, and still made lots of money. And that's, and okay, it was special circumstances last year. Prices were very high. And everybody's very sort of worried about the prospects of higher fossil fuel prices. But at the end of the day, if we're going to stop fossil fuels from causing global warming, they're going to cost more than if they do cause global warming, because it's cheaper to dump carbon dioxide in the atmosphere than it is to dispose of it responsibly back underground. But that's just the way it goes. And I think we need people to just get their minds around the fact that a responsible fossil fuel industry won't be quite as profitable, and its products will probably be a little bit more expensive than an irresponsible fossil fuel industry. But we'd rather have the responsible one, because then we wouldn't have global warming.
Yeah. And I guess that the challenge currently is, with the kind of cap and trade systems that we have, the price on carbon that they generate is much, much lower than that $250 per ton of CO2. So there's just kind of very little incentive for people to pay for direct air capture right now, unless we do something like tell the fossil fuel industry, oblige the fossil fuel industry to take back a ton of carbon dioxide for every ton of carbon dioxide that their product will generate.
Yeah, I don't think you get I think we've had sort of 20 years of 30 years in some jurisdictions of trying to price carbon dioxide out of the system, and um, I mean the proponents of carbon pricing argue, well, okay, it's not worked up until now, but now it's about to start working. I feel at some point you've got to call it and say, look, this just isn't working.
Hmm.
And um, my feeling is that essentially carbon pricing has failed. Um, it helps to weed out. It helps to weed out the sort of stupidest uses of fossil carbon. If you put a bit of a carbon price on, it does, focus minds, and it's a good way of getting emissions down by, maybe 10, 20, 30, even 50%. But it's a terrible way of getting emissions all the way to zero,
Right.
because, the more you need, if you just rely on a carbon price, people do the cheapest possible thing first. That's the idea. And they defer all of the most expensive mitigation options as late as possible. That's the way a carbon price works. And economists say, well, that's fine. That's what we meant to happen. But the problem is, if those expensive mitigation options, things like recovering CO2 back out of the atmosphere, take time to develop,
Yeah.
and they will, I mean, particularly if you're re-injecting carbon dioxide back into the Earth's crust, we can't do that overnight. We can't develop a multi-billion ton CO2 disposal industry overnight. It'll take us decades to get it built, and to convince the public that it's going to work, and identify the cases where it doesn't work, and make sure we don't make those mistakes again. It's going to be a process building this industry similar to the process of building the fossil fuel industry itself.
Yeah.
So we need to get on with it. And if we just wait for the carbon price to be high enough to motivate developing that industry, it'll be far, far too late. Which is why I think the only way to make it happen fast enough is regulation. Make it a regulatory requirement. If you want to sell fossil fuels, you've got to get rid of the CO2 they generate.
Right. Yeah. Yeah. I think it's a challenge that these are the only way to do this. It seems is with large scale infrastructure projects. It's not like wind or solar. You can buy a tiny wind turbine or a tiny solar panel, but you can also invest in a huge wind farm or a huge solar farm. You don't have that same kind of scalability or elasticity, I guess, in the scalability for carbon removal, and it makes it quite hard, it seems, to get going, and also to optimize and to bring costs down. We're probably not going to see the same learning rates that we've seen with renewables. On the other hand, the operational costs of running those facilities is going to come right down as renewables continue to offer lower and lower energy costs. Will that have a pretty big impact on reducing the dollar cost in removing CO2? Just the kind of, or is it sort of pennies on the dollar?
No, I think that is a really important interaction. I do think it's important that we don't. That for decades, we never seem to learn the lesson. We've sort of said, "Oh, the next energy source will be too cheap to meter." And people said this about nuclear back in the 70s, didn't work out. People say it about renewables now, and again, you've got to be careful about that, because humans are remarkably good at coming up with cunning ways of using cheap energy. So if renewable energy becomes too cheap to meter, someone's going to start using it to mine Bitcoin or
Right.
something,
Yeah.
and suddenly it won't be too cheap to meter anymore, because that person is using it all to mine Bitcoin. So I do think we need to be careful with that argument. There's definitely opportunities there, and in particular, one of the big concerns that people often get perhaps unnecessarily worried about is the so-called intermittency of renewables. The fact that
Yeah.
renewable energy, it's a little bit unpredictable, although you can reduce that unpredictability by spreading out your resources and diversifying and so on. But if you actually look at the numbers and you realize that if we're going to meet our Paris goals, the carbon dioxide disposal industry will need to be one of the world's biggest energy demand industries in the second half of this century. We're going to have this enormous industry which will need an awful lot of energy, um, which doesn't actually have to be running flat out all the
Right.
time, because if your job is disposing of carbon dioxide, you don't have to do it 24/7, 365 days a year. You just have to get rid of the right amount of carbon dioxide in a decade. So, in effect, this provides you with an almost limitless battery, if you
Yeah.
like, because you could vary this industry. If we designed it right, we could vary our carbon dioxide disposal industry to match the intermittency of our other energy supplies, so as to smooth out demand, and so we have nice predictable supplies of energy for everything else we want to use.
Yeah.
So there's opportunities there.
And is there really no kind of alternative way of putting carbon back into the crust? I mean, what about, for example, biochar? Like, is it just that the timescales? So biochar, you burn some stuff, you put the carbon into charcoal, and then I guess you kind of plow that into the soil. And I think that maybe hangs around for kind of hundreds of years, not the thousands, tens of thousands, maybe even millions of years that we expect from the geological storage proper. But is that, that seems something that's much more, easy to crank up on a smaller
Yeah.
scale, certainly.
And it has benefits as well. It can make agricultural land more fertile and so on as well. So it's certainly a helpful contribution indeed. If I'm offsetting a flight these days, I use biochar. I think that's the sort of best option available at the moment. But I'd rather be putting carbon dioxide back underground if that were actually available at scale, which of course it isn't at the moment, unless you've got very deep pockets indeed, and even then it's not available at scale.
And that's where I mess things up and the recording cuts out. So I'm going to try to fill you in from the contents of my memory. So at this point, Myles went on to point out that biochar, while it's achieved some scale, is never going to hit the scale that we need it to if it's going to suck out hundreds of billions of tons of carbon dioxide from the atmosphere. And that's the scale that Myles argues we do require if we're going to reach true net zero. So if it's not biochar and it's not planting forests, what is it, right? Is it just completely cutting our carbon use? And that's something that Myles argues is just infeasible as it looks right now. So what's left is direct air capture and other forms of carbon capture that's going to store carbon underground in geological stores. So basically geological storage, put it back where it came from. And how do we pay for that? Well, Myles has already alluded to it. So he mentioned how the fossil fuel industry, the natural gas industry at least, made enough money in the last year just from additional price rises caused by war in Ukraine to pay for putting all of that carbon back using established, albeit not running at scale, but established techniques. So the technology is there, but how do we make it happen? How do we incentivize it? And this is, Myles went on to mention here, the concept of extended producer responsibility. And this is something which already exists within the law. In the EU, there's many countries that have mandates around extended producer responsibility, mostly for packaging. So that means producers have to make sure that, or rather, let's put it like this, the responsibilities of producers for their packaging don't end once that packaging is in the hands of consumers. They have a responsibility to make sure that the consumers and the other infrastructure chains are able to properly dispose of their packaging. So how does this, what does this mean for carbon? Well, the original producers of carbon, or at least carbon that's taken from the crust, is the fossil fuel industry. And if they had a legal obligation to put back a ton of carbon into the crust for every ton that they took out, we would have true net zero. So Myles and I went to talk about a few other things. We talked about eFuels. Myles commented that he's a little bit frustrated by the airline industry's sort of apparently virtuous stance that they will use eFuels when they're ready, but they don't really seem to be doing a great deal to make them ready, and they don't seem to be doing enough in the meantime to abate fossil fuel usage. In his closing comments, Myles made 2 points which are worth dwelling on. One was the fixes for this crisis exist, and they're not sci-fi. They don't require completely upturning the world. We don't need techno fixes. We don't need to put sulfur dioxide into the atmosphere, for example. We know what works, right? We have direct air capture. We have a lot of renewables as well, but one of those things on their own may not be enough. So Myles' argument is we definitely need to be investing more in putting carbon back into the crust, just as we've invested so much in not taking it out with renewables. The second final comment was in response to my asking him, what is a hopeful but realistic outcome for COP28? And his reply was that he wanted to see a commitment to phase out unabated fossil fuel emissions. And he noted that if that comes about, that many climate activists would be unhappy with the language, with that word unabated, because it allows us to keep consuming fossil fuels. But Myles argues that we have to be realistic here, and he doesn't see a way that we will stop using fossil fuels, at least not on the timescales required. So if we're going to continue burning fossil fuels, then we need to start putting carbon back into the crust. One final apology from me for messing up the recording. It was a huge privilege to host Professor Myles Allen discussing these things, and I'm quite glad that it was the first part of the recording that we lost and not the second, because what was so crucial and came across so strongly in that first part is that despite all the complexities of modelling climate change and seeing exactly how it's going to affect us when and where, it's completely clear that if we want to stop global warming, it is not enough to hold the level of CO2 constant in the atmosphere. We need instead to stop the net transport of carbon from the crust to the rest of the system. I'm James Robinson. You've been listening to Multiverses.